So we are looking at quadratic function, and in this particular question, actually at the graph itself. Let's see. The graph of quadratic function h of x is shown in the diagram below, drawn to scale. Now that's important. That's the reason why it is in bold. The graph is symmetrical about a vertical line. What does that sentence mean? When something is symmetrical, that means we can fold it into two. And where is that line of symmetry in our case? So line of symmetry will be here, exactly at the very tip. If I draw a line, I could fold this into two. It will fold on itself perfectly. Okay, based on the graph, which of the following pairs of values of x is possible set of the roots of h of x? That is, values of x for which h of x equals 0. Okay, what are they asking me? They are looking for what? Roots. So what are the roots? Roots are those places where graph cuts the x-axis. So we don't know what is the value of x. We know that definitely value of y here is 0. But what is the value of x? What can we say from based on the graph? Well, we can say that this x will be a negative number because it's on the other side of 0, and this x will be a positive number. So that's the first criteria I'm going to consider. So here I have positive number and positive number. So definitely no, that's not an option. Then I have x as a negative number and x as a negative number. Again, that's not my option. So here I have negative and positive and negative and positive. Okay, so one of those should be good, but which one? Now, the next thing we can observe from the graph, well, how far is both of those x's, those points, from this point, and that point is 0, 0. So I can see that this one is quite away, isn't it? And this one is much closer. That means that the positive value is going to be bigger than the negative. So let's have a look at our numbers again. So negative is -2 and positive is 8. Let's just get a different pen. -2 and 8. Does that look reasonable? Yes, it does. What about the second one? -8 and 2. So this side has to be more further to be -8 for that to be 2, isn't it? So yes, indeed, that is my pair that I got for the roots. Okay, and then the next part. So the next part is saying find the value of x at which hx is minimum. So we have to understand what does that mean, minimum. So this place here in quadratic equation, that is the minimum place. This is where the value of this function is at lowest. So how do I find this value of x? Because they are not looking for value of y. That's not what I wanted to do. Let's get our graph a little bit here and let's consider it again. So what do we know about this quadratic graph? What do we know about it? That it is symmetrical, isn't it? So like what we said, if I draw a line here, it's exactly in the middle between what values? Here, these values we said is 8, and this value is -2. So the question is here, this value in the very middle, what is the value of x here? Well, from -2 and 8, how many units do we have? 10, isn't it? So that means that is exactly 5 units away. 5 units to 8, 5 units to -2. So obviously it's a little bit easier to use in the positive values than the negative. So from what value, if I go 5 units, I'm going to get 8? Well, yes, you are very right, is 3. That is the value of x here. If from x being 3, if I go 5 units, I'm going to get to the value of 8.